A solution that contains only two components is called as a binary solution. Then liquid and gas, you have chloroform mixed with nitrogen gas, and solid in gas, you have camphor in nitrogen gas. So it is important to study at least one example of these all solutions, which will be important for your examination point of view as well. It is given that mass by mass percentage is 10%. Okay, it's given here 10% glucose in water by mass. That means the mass percentage is 10%. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry. So today we are going to begin with the first chapter of your syllabus, that is solutions. So we will be covering all the concepts in this chapter. Right, so in today's session, as I already mentioned, we are going to study about solutions. So the introduction part we'll be discussing in this session. So today we are going to discuss what are exactly solutions. So in class 9 already you have an idea about what are solutions, right? Yes. So in detail we are going to study about solutions in this chapter. Then we'll discuss what is solute and solvent, different types of solution. That is, you have solid solutions, liquid solutions and gaseous solutions. Few examples we'll be discussing. And then concentration of solutions. That is the various ways in which we can determine the concentration of solutions. So mass percentage, volume percentage and mass by volume percentage we will be discussing in this session. The rest of the methods by which we can mention the concentration of solutions we will be discussing in the next session. So let us begin with understanding what are solutions. So you might be already familiar with this definition, that is solutions are homogeneous mixture of two or more components. Okay, so solutions are homogeneous mixture. Now what does homogeneous mixture means? Yes, there is a uniform composition throughout, right? So for example, if I am taking a glass of water and I'm adding 1 teaspoon of sugar to it and I'm mixing it, I get a homogeneous mixture. So in that you are not able to identify separately where is the sugar or water. It becomes a uniform solution, right? So such mixtures are called as homogeneous mixtures. And if you mix sand and water, what happens? After a while, the sand will get settled towards the bottom of the glass. So that is an example of a heterogeneous mixture. So homogeneous mixtures are called as solutions which is made up of two or more components. So you're already familiar with what are these two components, right? Those two components are solute and solvent, right? Solute and solvent are the two components. So in this level, you are going to study about only binary solutions. Now, what are binary solution? A solution that contains only two components is called as a binary solution. So we are going to only study about such solutions which are having only two components. That means it will have one solute and one solvent. That means two components, right? So there can be more than one solute and solvent, but we are going to only study about binary solutions, right? So solutions, it is made up of solute and solvent. So how can you identify which is the solute? Solute is present in the smaller quantity and solvent is present in larger quantity. So you're already familiar with this. So in this example also which we have taken, the glass of water, you have water here which is present in larger amount, that is your solvent, and sugar which we are adding in the lesser amount, that is the solute. So I hope that is clear. Now we are going to study about the different types of solution, that is solid solution, liquid solutions and gaseous solutions. So generally when we say about solutions, you will always think of solutions as liquid substances, right? But it is not just liquid solutions, you have solid as well as gaseous solutions. So we are going to study about that with few examples as well, right? So first let's begin with solid solution. So how can you say whether a solution is a solid solution? Is that, as we have discussed now, in solution you have two components, that is solute and solvent. So when the solvent is in solid state, we call it as a solid solution. So that means your solute can either be a solid, liquid or gas, but solvent will be always a solid. The solution in which the solvent is solid and solute can either be a solid, liquid or gas are called as solid solutions. So example is alloys. So in the solid solution itself, you have three types, that is solid in solid solution, liquid in solid solution, gas in solid solution. Now first, what is this in I have written here? Solid in solid. That means the first solid stands for solute and the second solid stands for solvent. Okay. So solid in solid means solute is solid, solvent is also solid. So examples are alloys. Okay, so alloys means it is a mixture of different metals, right? So both of them are in solid state. So that is why solid and solid. Then you have liquid and solid. That is solute is liquid and solvent is solid. I hope it is clear. See, again you can see the solvent is solid itself. That is why it is a solid solution. So example is amalgam of mercury with sodium. Okay, amalgam of mercury is in the liquid state and sodium is in the solid state. Now you have gas and solid, that is solution of hydrogen in palladium. Right. So here also you can see gas is a solute and solid is again solvent. Clear? So these are the solid solutions. Now the same way you have liquid solutions. So now you can itself tell what are liquid solutions then? Yes, the solute can either be a solid, liquid or gas, and the solvent will always be a liquid, right? So just by knowing the solvent, you can tell whether it is a solid, liquid or gaseous solution, right? So the solution in which the solvent is liquid and the solute is either a solid, liquid or gas are called as liquid solutions. So same way that we have discussed in solid solution, here also you have three types in liquid solutions. One is solid and liquid solution, right? So here the solute is solid, liquid is solvent. So glucose dissolved in water or sugar dissolved in water. So all these are examples of solid and liquid solutions. Now you have liquid in liquid solution, that is both are liquid, solute and solvent. So ethanol dissolved in water is an example of liquid and liquid solutions. Now you have gas in liquid. So this is a very important example, gas in liquid, that is oxygen dissolved in water. Okay, oxygen is in the gaseous state, dissolved in water. Now where it is important, oxygen dissolved in water. So this is how the aquatic animals survive, right? They can't come above the surface of water and breathe, right? What about the fishes and other aquatic animals? They take up the oxygen which is present inside the water itself, that is dissolved in the water itself. So that is gas in liquid solutions, right? The last one is gaseous solutions. So of course the solvent is going to be a gas and the solute can be either a liquid, gas or a solid, right? Solution in which the solvent is gas and the solute is either a solid, liquid or gas. So again you have three types, that is solid in gas, that is solute is solid, solvent is going to be a gas. So camphor in nitrogen gas is an example, and liquid in gas, chloroform mixed with nitrogen gas, wherein liquid is a solute and gas is a solvent, and you have gas in gas, that is mixture of oxygen and nitrogen gas. In general you can say air, that is a gas in gas solution. Okay, so these are the three types of solution. So now let's just summarize this. The first one is gaseous solution. So gaseous solution means the solvent will always be a gas. So solute can either be a gas, liquid or solid. So gas and gas you have mixture in oxygen, nitrogen gas. Then liquid and gas you have chloroform mixed with nitrogen gas, and solid in gas you have camphor in nitrogen gas. So it is important to study at least one example of these all solutions, which will be important for your examination point of view as well. Now you have liquid solutions wherein the solvent will be always liquid. The solute can be gas, liquid or solid, right? So gas in liquid, you have oxygen dissolved in water. As I have already mentioned, it is important for the aquatic animals, right? Liquid in liquid solutions, ethanol dissolved in water. Solid in liquid, glucose dissolved in water or sugar dissolved or salt dissolved in water. Now you have last one, that is solid solutions. Again, the solvent will be always solid. The solute can either be gas, liquid or solid. Right. Examples can be solution of hydrogen in palladium, for gas in solid, for liquid in solid, amalgam of mercury with sodium, and solid in solid, of course, the example is alloys. So I hope the different types of solutions is clear for you. Now moving on to the next part, that is expressing concentration of solutions. So first of all, what is concentration of a solution? It is the amount of solute which is present in a particular amount of solvent, right? So as you can see, the concentration of the solute is the amount of solute present in a given quantity of solvent or solution. How much amount of solute is present in a given amount of solution, that is called as the concentration of the solution. So why is it important to express the concentration of the solution? So let us take an example here. As you can see here, this in a beaker we have taken water, okay, and we have added few drops of or few crystals of copper sulfate. Copper sulfate crystals you have seen, it is blue in color, right? Few crystals we have added, you will get a very light blue color. Few more we have added, you get a dark blue color. And few more if we add, you can see here we are adding more, it becomes a very dark color. So without knowing about how much amount of or how much quantity of copper sulfate I have added, we can tell in which of these beakers the concentration of copper sulfate is more. Of course, it will be the darker one. Just by seeing the color, we can tell. Yes, this one will have the highest amount of copper sulfate. That is, the concentration of this solution is more than this one, and this one is having the least concentration by just seeing the color. Even if I don't know how much quantity of copper sulfate I have added. But it is not in the case of all the solutions. All the solutions will not be colored, right? Then how do I determine the concentration of solution? So there are various methods in which we can determine the concentration of the solute. That means how much amount of solute is present, right? So the different methods are mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity and molality. So the first three we'll be discussing in this session, right? So the first one is mass by mass percentage or mass percentage, right? It is represented by W by W. So the W stands for mass, okay? So mass percentage is defined as the mass of the solute dissolved in 100 gram of the solution. That is, how can you determine the mass percentage of the solution? That is mass of the solute, right? Mass of the solute by total mass of the solution into 100. It is in percentage, right? So it is into 100. So mass percentage is mass of component in the solution. So if you need in terms of solvent, you can use mass of solvent, or else if in terms of solute you want, mass of solute you can take. That is why it is written mass of a component in the solution divided by total mass of the solution into 100 will give you the mass percentage. So if a solution is described by 10% glucose in water by mass, or else it is given that mass by mass percentage is 10%. Okay, it's given here 10% glucose in water by mass. That means the mass percentage is 10%. So what does that 10% mean? So it means that 10 gram of glucose, it means that 10 gram of glucose is present in totally 100 gram of solution, or else you can say 10 gram of glucose is present in 90 gram of water, so that it together will give 100 gram of solution. Clear? So just by seeing the 10%, what you have to identify or understand from that is that 10 gram of glucose is dissolved in 90 gram of water, or 10 gram of glucose is dissolved in 100 gram of solution. Clear? So this is mass percentage. It is commonly used in industrial chemical application. Right. Next one is volume percentage. So it's the same equation but in terms of volume. So volume percentage will be volume of the component in the solution, that is volume of your solute, divided by total volume of the solution into 100. Clear? So this unit is useful when both the solute and solvent are liquids. See, when both are liquids, we use volume, right? We can't use the term volume for a solid or gaseous substance. So we use generally when both your solute and solvent are liquids, right? Now 10% ethanol solution in water. So this is an example. So again, 10% ethanol solution in water. So what does that mean? Volume percentage is given as 10%. That means 10 ml of ethanol is present in 90 ml of water, so that you get 100 ml of water. So that means that 10 ml of ethanol is dissolved in 90 ml of water, which will give you a total of 100 ml of solution. Clear? Now the last one is mass by volume percentage. So that is W by V. Okay, that is, how do you represent it? Mass of the solute and total volume of the solution. Before we have discussed mass by mass percentage, volume by volume percentage. This is mass by volume percentage. That means mass of the solute divided by total volume of the solution into 100. Do not forget to mention this 100. The value will be wrong, right? So this unit is useful when solute is solid and solution is liquid. So in this case, you can use mass, we can consider for solid. Volume we can consider for liquid, right? So when the solute is solid and solvent is a liquid, you can use this method, that is mass by volume percentage. This unit is commonly used in medicine and pharmacy. So I hope it is clear, right? Moving on to the next one, that is parts per million. It is defined as the number of parts of solute dissolved in 1 million parts of the solution. So this is not in percentage. That means it is not into 100. The difference is it is in million. So it is into 10 to the power 6. So it is in parts we are mentioning, that is number of parts of the solute divided by total number of parts of all the components in the solution into 10 to the power 6. So parts per million can be also expressed in mass by mass, volume by volume or mass by volume percentage. That means Even if we want to measure it in terms of parts per parts million, we can either use all the three equations that we have studied before itself, but it will be in million. That means if I have to mention in terms of mass by mass percentage, I'll write mass of solute by total mass of solution into 10 to the power 6. So generally the equation is number of parts of the solute divided by total number of parts of all the components in the solution into 10 to the power 6. So that is important here, it is in million. Okay, so this unit is suitable only when the solute are present in trace quantities. So this method is generally used to measure the pollution or the extent of pollution present in the air around us. So only when the amount of solute present is very less compared to the whole solvent or solution, if the amount of solute present is very less, we use this method, that is parts per million. Clear? So in the next session, we are going to discuss about the further concentration terms, that is mole fraction, molarity, molality, and we'll move on to the next part, that is solubility. So I hope the concepts that I've covered in this session is clear for you. So that's all for today. Thank you.